If we start with exponential function f defined by as a 2 to the power x, okay, so this is the y, and interchanging the variable change the variables, we will obtain the following one: x equals to the power y. We call the inverse the logarithmic function with base 2 and write, so from here you can obtain the y in terms of the x, so we use the new notation. So this equivalent to this equation, we say that y equals logarithm base 2 of x, okay? So this implies y equals logarithm base 2 of x. This is just definition, okay? So we use this notation. So as a result, y equals logarithm base 2 of x if and only if x equals to the power y. So this means if and only if. Okay? The meaning of this notation, if and only if. So y equals logarithm base 2x implies x equals to power y. X equals to power y implies y equals logarithm base 2 of x. We can graph y equals logarithm base 2 of x by graphing x equals to the power y, since they are equivalent. Any ordered pair of the number on the graph of exponential function will be on the graph of the logarithmic function. If we interchange the order of the components, for example, let's talk about the example. We have already sketched the graph of 2 to the power x. This is 2 to the power x. But we need the graph of the x equals to the power y to sketch the graph of a logarithmic function. But here, this is the order of the components change. Okay, we interchange the order of the components. So, for example, 3 to power 8 is onto that point. This is 3. So y is 8. 3.8. So 8.3 satisfies this equation. 8.3, x is 8, y is 3. Okay. So 8.3, let's show that. 8, 3, somewhere here. Maybe my sketch is not good. Yes, this intersection is 0.1, so my sketching is not good actually. Anyway, this point is on the curve. Is on this point. Sorry, this point is on this graph or graph of the logarithmic function. And again, it has to be positive at the point 1. Also, you can consider you change the x and y coordinates. So by rotating or by taking the symmetry about the y-axis, you can find the graph. So that graph, we should symmetry about the y equals x. Sorry, we should take the symmetry about the y equals x. So by taking the symmetry y equals x, we can sketch the graph of the logarithmic function. So which will be like this one, passes through to 0.1. Okay, so the blue one, it is maybe not good, but we can say that the graph of the y equals logarithm base 2 of x is this one, and x-intercept is 0.1, and there is a vertical asymptote which is y-axis. So now we can define the logarithmic function by according to this observation. definition of logarithmic function. The inverse of an exponential function is called a logarithmic function. So for b bigger than 0 and b is different than 1, y equals logarithm base b of x. This is a logarithmic function. Logarithmic form is equivalent, so if and only if equivalent to x equals b to power y. That is exponential form. The logarithm log, notation log to the base b of x. So we read, not this one, sorry. We read that one. Log to the base b of x. Log base b of x in short sometimes. Is exponent to which b must be raised to obtain x, okay? The domain of the logarithmic function is the set of all positive real numbers. From this graph you can observe for the negative value of the x is not definite, so positive real numbers, okay? Let's emphasize domain of the logarithmic function equals positive real numbers, which is also range of the corresponding exponential function, okay? It's equal to the inverse function, and the range of the logarithmic function is the set of all real numbers. So the range of the logarithmic function is all real numbers, which is also domain of the corresponding exponential function, of course. So typically graph of the exponential function and its inverse, a logarithmic function, can be given as the following graph. Okay, so this is the graph. This is logarithmic function graph. So exponential function graph y equals b to power x, and which is symmetry about the y equals x axis, and that is the graph of the logarithmic function y equals logarithm to the base b of x. Okay, by considering the property, by talking about properties of logarithmic function, let's complete this record. The properties of the exponential function. So logarithmic function, not exponential. Lead to properties of logarithmic functions. The properties of the exponential functions lead to properties of logarithmic functions. For example, consider the exponential properties. Let's derive p to power x, p to power y equals p to power x plus y. So by saying this is capital M, this is capital N, so b to power x equals n, b to power y equals n. So this implies logarithm base b of m equals x, and this implies logarithm base b of n equals y. So maybe we can take the logarithm of the both sides, but anyway, there is no problem. So from the first equation, we obtain n times n equals b to power logarithm base bm plus logarithm to the base b of n. So by the properties of logarithmic function again, from here we can say that logarithm to the base b of m times m equals this summation. So from here, logarithm base b m times n equals logarithm base b m plus logarithm to the base b of n. Okay, so we obtained this important property. And similarly, you can obtain some other important properties. So let's write all of them as a list. So the first property is logarithm base b of 1 equals 0. Second one, logarithm base b of b equals 1. By definition, you can obtain easily. Logarithm base b of b to power x equals x. The fourth one is b to power logarithm base b of x, which equals x again, but here x to be bigger than 0 because of domain of the logarithm. The fifth property, logarithm base b m times m, which is obtained here. We obtain this result. So logarithm base b m plus logarithm to the base b of n, and similarly logarithm to the base b m over n equals logarithm to the base b m minus logarithm to the base b of n. 7, logarithm base b m to power p equals p times logarithm to the base b of m. And the last property is logarithm base b m equals if logarithm base b n, if and only if m equals n. In the future I can use, but this means if and only